Okay, the question today is how can time be asymmetric? And it's really about what is the origin of number, what is the origin of the one. And in science, even the inverse of time is period, whereas the inverse of momentum is wavelength. And or the inverse of frequency is wavelength, and frequency is directly proportional to momentum in quantum physics. So the Louis de Broglie momentum as wavelength is taught in quantum physics, but it's not taught that it originates from his law of phase harmony, which is the basic idea that as a particle goes towards the speed of light, the frequency as momentum goes up from quantum physics, but the time also goes up or gets bigger and slows down according to relativity. And from Pythagorean music theory, because time is inverse to frequency, therefore this is a logical paradox that is logically solved by there being a second time from the future that's guiding the particle. Now, Louis de Broglie regretted his concept of the pilot wave because it assumes a space-time medium. And Albert Einstein, at the end of his life, realized that space-time as a continuum would have to be dismantled, and that would require dismantling his whole theory of relativity. And he realized that the Heisenberg algebra would be the key to the truth of reality. And Basil J. Hiley has a great quote about this from Einstein, an Einstein quote that he uses in his papers. So when we learn Pythagorean music theory, the one as number is not actually a number because it's light as consciousness. But then when we double the one as the fundamental tone, we are listening to the source of the one, and that is a octave as the same pitch. And so in terms of geometry, it's symmetric. So it's the same geometric pitch as, so if you call the one a C, then the octave is also a C. And then the frequency is actually the ratio, a geometric ratio of space-time, but in terms of noncommutativity, it's actually a ratio of time as period with frequency before space as a wavelength. And so even the concept of period in Western science as the inverse of time assumes the period is a magnitude, as a geometric magnitude. And what noncommutativity is stating, and this is what Roger Penrose relies on, and Basil J. Hiley, and Alon Kahn, and Lou Kaufman, they're stating that time is an absolute that exists on its own. And this is the case in quantum physics. In relativity, time is just a indirect relative measurement that's dependent on the unit being measured. So this is a logical paradox that goes all the way back to the Pythagorean theorem. And if you read the philosophy professors Philip Hugley and Charles Sayward, their article, Did the Greeks Discover the Irrational? And they had an article in 1999, and their answer is no, because the proof for the Pythagorean theorem as the square root of 2 has a logical disconnect between geometric length that requires a unit and arithmetic as distance that's just pure number. And so you cannot positively state that because the two ratios as numbers are not rational, that therefore they are the square root of 2 as a unit, because the numbers have to be as the same unit in length, but there's no geometric length as unit to compare them to. And so in music theory, the square root of 2 was first approximated by the major second music interval as 9/8. That was then cubed as the tritone, which is called the devil's interval because it's considered the most dissonant music interval of the scale for the octave. So the tritone is the geometric mean of the scale, and it's derived from the equation, the arithmetic mean as the perfect fifth plus the harmonic mean as the perfect fourth equals the geometric mean squared as the octave, which is 2. And so 9/8 cubed originates from the perfect fifth as 3/2 that then is squared as 9/4. But then that is halved back into the same octave as 9/8. And that gives you the major second as a geometric mean, or a geometric magnitude for wavelength, or for period as the frequency that's inverse to time. So the one as defined by time is assuming a geometric mean as a symmetric magnitude inherent to the period of time. Whereas in noncommutativity, the one of time is inherently syncopated as asymmetric time, and therefore it's called by Alon Kahn 2 3, and infinity. And what this means is that when 9/8 was created for the major second music interval by Philolaus, and then codified by Archytas as from the arithmetic mean as the perfect fifth or 3/2 plus the harmonic mean as the perfect fourth or 4/3 equals the octave as 2, or the geometric mean squared, and therefore the geometric mean is the square root of 2, which is the 9/8 cubed. And the 9/8 is again from the 9/4 that's halved back in the same scale, and the 9/4 is from 3/2 squared. Now, that squaring process is a geometric symmetry of the time and frequency, but it only can occur by having a covering up the noncommutative source of the one as an inherent asymmetry. So when we logically infer the source of number as the one, it is logically an asymmetric time that's eternally flowing as syncopation, syncopated time, as 2, 3, infinity. So what Philolaus did is that in order to create the perfect fourth, he used the common denominator of a double octave for 12 as 12. And so he said the geometric mean squared of the octave is from a double octave, and this enabled covering up the different values of the one. So he used 0 to 8 as a 1 value for the wavelength or the magnitude, and then he used 0 to 12 as the fundamental tone, or 1 as a geometric magnitude. And so then he was able to derive 6/8 as the wavelength for a 8/6 frequency as 4/3 from the 0 to 8. And he did that by flipping his musical instrument around. He flipped the lyre around. And so once he was able to establish 4/3 from the 1 of 0 to 8, then he was able to add that to the 8/12's wavelength or geometric mean of 0 to 12 for the perfect fifth as 3/2. So he used two different geometric magnitudes of the one, and the reason he did that is because 4/3 as a natural overtone does not exist, because the ratio of time has a different denominator to the one. So in order to have a natural overtone, the denominator has to be the same geometric octave in pitch to the one. And so you cannot have 3 in the denominator for an overtone as 4/3. So instead, when you learn the harmonic series, they just call them ratios and not overtones. And so 4/3 can never be an overtone. Now, if you're actually listening to the overtones and you hear a perfect fourth that's a higher frequency than the fundamental tone or root tonic of the 1, then your ear will hear a new fundamental tone or octave that is an undertone of the perfect 4th as the perfect 5th in the reverse direction of time. And so the reverse direction of time is actually a non-commutative asymmetry of time, and it's not a symmetric magnitude of time. And therefore the logical inference of the source of the 1, which is also the source of the I thought, is actually this infinite asymmetric 2, 3 infinity. And the octave then is actually not symmetric inherently, and it's actually expanding as an infinite spiral that cannot be seen. And due to the exponential growth of the octave against the perfect 5th, then you have a music that has a geometric dimension of 0 because it's less than any positive number as a real number in a symmetric space-time continuum. It's more dense. And this is proven by the fact that 3 to the 12th as the perfect 5th against 2 to the 19th for the Pythagorean scale of 12 notes in the scale is then divided back into the same music octave as 2 to the 1/12th and 3 to the 1/19th. And so the exponentials are non-commutative because you add the 7 and the 12 for the ratio of 3.5, because the 7 is the perfect 5th music interval for the 12 note scale. So you have C, C sharp, D, D sharp, E, F, and then F sharp, which is the tritone, and then G, which is the 7th note of the scale, and that's added to the octave, which is the 12th note of the scale. And that's why you have 3 to the 19th against 2 to the 12th, or you have 3 to the 12th against 2 to the 19th, or you have 2 to the 1/12th against 3 to the 1/19th. And so that the square root of 2, which is used for the equal tempered music scale as the 12th roots of 2 for the geometric magnitude of the 12-note music scale, is actually derived from this non-commutative rational division and multiplication process that's non-commutative time as an inherent asymmetric time, and so it's inherently syncopated. And this is why you can derive frequency from time by speeding up ratios of time and period, but in fact those ratios are inherently asymmetric. And this is, you can demonstrate this with the rhythm of 2 against 3. So whenever you do 2 against 3, you get the inherent